No. Hello, can you hear me? Hello, guys, can you hear me?
I can hear you.
Yes, I can hear you.
How are you guys doing?
Good.
Good, good.
Good.
Professor, may I speak to you after class, please?
Yeah, sure. So, again, I'm here. I couldn't make it to the campus, but goodness, sorry, I think I missed something at PP. So anyway, here we are again. But this Thursday I'll be there. I actually was there yesterday. Was there yesterday, but today I couldn't make it. So I decided to have it again remotely. Now let me start by showing you the announcement for the week. And when I do that, I want to show those of you that qualified with a 70% score on the attendance who requested for makeup last week. If you did that, I want you to check your email because I sent the makeup work for you. You can see if just follow the direction of the email. And if you haven't done so yet, and the attendance is up to 70%, remember you can still make up 5%. Now, if your attendance is not up to 70% this week, you still have till December 10th to push it up. Then you can request. After December 10th, you can't do no more because we'll be working on final grades that time. So anyway, and then for the project group, I have some of you have already shown me their group, and I still have to set up the other group members in the project. But I want to do it in the classroom so all of you can see who and who belong to your group. So probably on Thursday we'll do that on Thursday. For this week we continued and finished chapter 9 on test of hypothesis. And then actually we finish it next week. If time permit. Because I learned that next week is the Thanksgiving week, I believe. Yeah, I think next week is Thanksgiving week. Anyway, we try and finish it next week on Tuesday, hopefully. And next is the three assignment, homework 9, then test 2. Both of them are due on this Sunday. Now, the project I've already mentioned that I will assign the group. Those who have already sent me their name of their group, you can start working on the project. And that's it. So let's begin. Last week, I introduced you to test hypothesis, and we even did a classwork on how to state hypothesis. So now today let's do the actual work. Let's start, digging till the ground on hypothesis testing. We're gonna do that using Z-test for the mean. There are two methods: the traditional method and the p-value method. Now, today we'll be looking at the traditional method. On Thursday, we'll be doing the p-value method. Yeah. For a traditional method, as you can see from the screen, we follow these steps. Working rule says, state the hypothesis and identify a claim. Last week, I showed you how to state hypothesis. Find the critical value from the appropriate table. Then run the test. Or another way of saying it is to compute the test value. Then summarize the results. Make the decision. Before you summarize the result, make the decision to reject or not to reject non-hypothesis. Then after that, you can summarize the result. So what is the decision criteria? What is the criteria for making the decision to reject or not reject non-hypothesis? The criteria is this. I'm going to highlight it. You reject the non-hypothesis if and only if the calculated value, which is your answer, is bigger or is equal to the critical value. Otherwise, you don't reject. So to run the test, we use the test statistics. Z equals X bar minus mean divided by the standard deviation over root n. We are familiar with this formula. We use it when we are doing central limit theorem under normal distribution. Here, S bar represents the sample mean, mu represents the population mean, and delta represents the population standard deviation, and n represents the sample size. So let us use this, run the test for the two examples. Let's do two examples on this. The first example will be on this one here. It says that a researcher, I gotta move this in down so we can have enough room here. So a researcher reported that the average annual salary of assistant professors in the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260 at alpha 0.05. Test the claim that the assistant professors earn more than 42,000 in the year 1997. The standard deviation of the population is 5,230. Now, anybody reading this might say, okay, they are claiming that it is more than 42,000. And a sample of 30 assistant professors has an average salary of 43,000. So that means which is bigger. So why are we doing the test? It's already bigger from this sample. Yes, of course, we need to do this test because this is only a sample of 30 assistant professors. And we have thousands of them. Besides, we don't know how the sample was collected. Maybe they came from the same college. We know that there's difference in payment scale, even in Maryland here, even in Baltimore. Coppin State pay more than Baltimore State Community College. Morgan pay more than Coppin, and Morgan's Community College of Baltimore County pays more than Baltimore State Community College. And they are totally, so it might even come from one sample. Also, we know the population standard deviation has to be 5,230. So we still need to do the test. We don't have this. This does not represent all the assistant professors in America. So that's why you need to, and plus given the fact that they give us the population standard deviation, we still need to do the test. So now, anyway, let's identify the keywords here. The keyword is average. Say average annual salary. Say average salary. See, the average is maintained. The other one is is more than. Another keyword. Okay. Right, of course, and more than. Okay. All right. Having said that, we're ready. Let's state the hypothesis. HO and H1. And H1. Like what I told you last week, HO and H1, they say something different, opposite of each other. Okay? HO now, it said that to test the claim that the assistant professor earn more than is greater than, and we can only use greater than symbol in the alternative hypothesis. So we're gonna put it, that's where the claim lies then. Okay. Mean, okay, is greater than 42,000. That's the claim right there. Okay. The other one is mean should be the opposite, which is less than 42,000. However, we cannot use less than symbol in the null hypothesis. We can only use less than or equal to symbol. So you're gonna be mean, excuse me, sorry. Mean is less than or equal to 42,000. Okay, 42,000. And they give us the alpha to be 0.05. That means your chance of committing type 2 error is 5%. So that means the chance of being right is 95%. I mean, anyway, since this is pointing on one direction, and the claim is on the right direction, we call it a right third test. A right third test. And if you remember when we did normal distribution, when we were using procedural chart, if it falls in any of the tails, and if you're using this table that I showed you at that time, okay, which I recommend you continue using. I mean, the one in your home in the Pearson, MyLab, and Master is cumulative type. If you know how to use that, fine. But for this table here, standard number distribution, this one is not cumulative. So for this one, you're gonna follow the method I'm teaching you today. Okay. Follow the methods, and then you should be fine. So now, and based on that, I remember I explained and gave you many examples when we were doing normal distribution that if it is on the tail, you subtract the area from 0.5 to get the critical value. So now look at the critical value here. Now the critical value we got when we are doing confidence interval is on two sides, say lower side, lower interval, upper interval. So that one is for 2 tail tests. So you can use the formula that we use for finding critical value for confidence interval. You can use it when it is 2 tail tests. We're gonna do a 2 tail test after this one, but for this one it's only right tailed. So you cannot use that formula for this one. You can use this one. I'm about to show you now. Critical value, since it is only one tail, it's not going to be alpha over 2. You have a Z alpha only. Z alpha equals 0.5 minus 0.05. And I'm going to explain in a minute. I'm going to explain this. They say that a diagram speak more than 1,000 words. So I'm going to use a diagram to show that. So let's see, look at the diagram right here. We have 0 and our Z alpha, which we don't know what it is yet. I'm going to show you with the diagram. Now, I'm going to draw this chart. Okay. Put the normal curve. Okay. Then I'm going to move it. Okay. Now, put the center line. Put the center line. Okay. Then it's on the right side. I'm putting on the right side. So so I remember that like I said, when we are doing my distribution, I told you that there were many examples. We give an example that if it's at the right tail or left tail, you subtract the area from 0.5. I'm sure you remember that. So that's why we are doing half of this is 0.5 and half of this is 0.5. If you're looking for only this part, that means you gotta do 0.5 minus this shaded area. And that gives us 0.5 minus 0.05. Okay. 0.5 minus 0.05. Okay. Let's go and put it on the calculator. Why is my calculator? Okay. Because in 1 minute, I'm gonna put it up. Okay. So we're gonna have it right here. 0.5 minus 0.05. 0.4500. 0.4500. Now we can now go to the table of normal distribution to find the value that corresponds to this. I mean, if we see exactly this number, remember this is 0.45, but because all the digits in that table are 4 digits, that table have 4 digits each. So you use these 2 zeros to make as the place value to complete it to 4 digits. If you see a number that is exactly this, we can use that. If you don't, we can choose a number that is closest to it. So we have them here, 0.450. So ignoring the decimal point, 4500, I didn't find it. I only find 4495 and 4505. Let's see which of them is closest. 4495. So 4500. Oh, excuse me. 4500 minus 4495 is 5 points away. Okay, let's try the other number. We try this. This doesn't is 5 points. Let's try this one. 4505 as well. Four 505 minus 4500 is 5 points up. So both of them are equally close. So when it happened that way, you choose the bigger one, which is this one here, 4505. Now if you look it to the left, 1.65. 1.65. Okay. Again, if you look to the left, 1.65. That will become our critical value, 1.65. Okay. 1.65. So what we're going to have here is 1.65. Okay. Now we have our critical value as 1.65. So now we can run the test. Remember that if our answer falls in this critical region, we reject the null hypothesis. Reject HO. Okay. If it falls in this critical region, you reject, this is the critical region right here. Anywhere in this shaded place, you reject HO. But if it doesn't fall here, this side is the acceptance region. On shaded place, accept. So in that case, if it falls there, you don't reject. Okay. Now let us run it. To run the test, we need our summary statistics. We were told that the average salary assistant professors in 1997 is 42,000. So population mean mu equals 42,000. Okay, let me write it down here. Okay, make sure I've seen this. So that mu equals 42,000. Okay. Okay, now to test this claim, that is more than they selected a sample of 30 assistant professors. So N equals 30. For these 30 assistant professors, they found that they found that the mean salary is 43,260. Let me write this down. And it's that mean of that X sample mean would that become 43,260. That is our X bar. Got our X bar X equals, I want to make this to be 18. S bar, so it's gonna be S bar, so I'm gonna put the bar on top of it. I forgot a different way of doing it. X bar equals 43,260. Okay. And the sample standard deviation. Okay. Sample standard deviation. Make sure I got this. They told us that the standard deviation is 5,000. You can see right here, 5,230. Delta is 5,230. So I'm gonna write it there here. Okay. Standard deviation, which is delta. Okay, equals 5,230. So these are the things we need to run the test. Remember the formula is Z equals S bar minus mean divided by standard deviation over square root of n. And this is the value numbers we have here for it. We are going to go to the, since this place will not allow you to put the formula, I'm going to take it to the other workbook so we can put the formula and run the test, okay? So right here. So I'm going to move all this. I just taught the other class, so that's why you've seen this. Okay. So now let's run the test. You have a sample mean of 42,000. Okay. 42,000 minus, oh, my mistake. Sample mean is 43,000. Let's look at it again. Because sample mean is the X bar. So 43,260. Population mean is 42,000. Sample size is 30. And standard deviation is 5,230. Let's go and plug in. Okay. So sample mean is 43,260. Population mean is 42,000. Standard deviation over square root of n, which is 5,230 divided by square root of 30 assistant professors who have a sample. Okay, let me plug this in my Z equals 43,260 minus 42,000 divided by standard deviation of 5,230 over square root of 30. Let's calculate in the calculators to get our answer right away. Okay. We got 43,260. Oh, excuse me. 260 minus 42,000 divided by standard deviation of 5230 over square root of 30. 1.319561073, which is approximately 1.32. 1.32. Okay? 1.32. So you go and put it in. Then transfer it to a main workbook. 1.32. So I copy this. and paste it in the memo book. (1.32) or Z. So I calculated Z 1.32. You can see that this is one critical value 1.6. 1.32 is less than that because it falls in the acceptance region. Now let's make our decision. Decision. Okay. Critical value. Which is a Z alpha. Okay. So Z alpha. Okay. Alpha equals, what do you have for this? We got it as 1.65. Okay. Calculated value. Calculated value. That's our answer. Calculated Z equals 1.32. I hope you still remember the decision criteria. Decision criteria is this. Reject the null hypothesis if and only if the calculated value, which is your answer, is greater than or equal to the critical value. Otherwise, don't reject. In our own case, our answer is less than the critical value. So it's not equal to it. So do not reject. Reject. HO. Since the calculated value Z equals 1.32 is less than critical value. Value of 1.65. So that means that we don't reject. That means we do not reject the hypothesis. We do not reject this. We did not reject the null hypothesis. That means we are not accepting the claim. Since that means we did not reject, that means we're accepting this one and did not accept this one. So this is where that means there's not enough. The claim is wrong. So we can say that there is not enough evidence to support the claim. Okay, that's all as a conclusion. Decision is not to reject. So a conclusion. There is insufficient evidence to support the claim that assistant professors earn more than $40,000 in 1997. Okay. So there's not, since we didn't reject it. Any question on this? No question. Good. Excellent. Excellent. Let's do another one where you have 2 tail tests, like this one here. It says, I'm gonna move this down so I have the option. You see here that the medical, yeah. Just 1 minute. Just 1 minute. Sorry. Yeah, baby.
Okay.
I come on a class.
Okay, still you've done your yapaka.
Okay, what happened?
Me, come on.
So the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is 24,672. That's what they claim. So to see if the average cost of rehabilitation is different at a particular hospital, a researcher select a random sample of 35 stroke victims at the hospital and find that the average cost of their rehabilitation is 25,226. The standard deviation of the population is 3,251. At alpha 0.01, can it be concluded that the average cost of rehabilitation at a particular hospital is different from 24,602? So this is the Medical Rehabilitation Education Foundation. They made this claim that the average cost. So let's look at the keywords there. Keywords here is to be have the average cost right here. Okay. Then is means equal. Okay. And we can only use is. Excuse me. You can use equal sign symbol in the null hypothesis. So now, having said that, let's state the hypothesis. Solution. HO and H1. Okay. And the HO is well, let's say the average, their claim was the average cost of rehabilitation is 24,672. Let me write this down. Okay, as a matter of fact, it's there already. It's on the screen, so you can see. Let me make sure of that very well. Okay. So HO, say HO, I'm sorry, my mistake. The average cost as mean is equal to 24,672. Mean equals 24,672. The claim, what he's claiming, right? H1 is different. He said that this researcher is trying to find out if it is different. So if it's different means it can be less than, it can be greater than. So it doesn't tell us whether it's less than. So it's two sides. So that means mean, okay, not equal to 24,672. Excuse me, 72. And we are told that the alpha is 0.01. That means your chance of being committing a type 1 error or being wrong is 1%. So being right then is 99%. So now let us find the critical value. So now because it says not equal to or equal to, that means it can be left or right. In that case, you can use the same formula we use for finding the critical value of confidence interval. But because it can both sides, it can be either side. Call it a two-tailed test. Two-tailed test. And for two-tailed tests, you can use the same formula, their shortcut formula I showed you when we are doing a confidence interval, which is the P over 200. So this time we're going to write Z alpha over 2 since there's two sides. The critical value Z alpha over 2, Z alpha over 2, alpha over 2 equals, okay, Z alpha over 2 equals, let's find, we're going to use P over 200. The shortcut formula I devised for this. 200 is, see, percent is 100%, over 100. But this is two sides. I used, 200. And what is our P here? If you have a 1% chance of committing type 1 error, that means you have 99% chance of not committing it. So P will be 99 over 200. 99 by 200. 99 divided by 200. 0.495. 0.495. 0.495. No, not 495. Sorry, my mistake. Yeah, sorry, 0.495. Yeah, I'm right. 0.495. 0.495. Now, put 0 because the digits in that table is 4. So use 0 as a placeholder to make it 4 digits. Now, look for this on the table. If we see the number exactly, we can use it. Or if you don't see it exactly, we can use the number that's closest to it. 4950. 4950 in the table of normal distribution. I couldn't find it. I only find 4949 and 4951. Both of them are 1 point away. You can verify this with your calculator. 4951 minus 495. Or 495 minus 4949. You can verify with your calculator. Both of them are equally close, 1 point away. So I'm going to choose the bigger one since both of them are equally close. Follow it to the left. 2.5 up 8. So 2.58. 2.58. Okay? 2.58. But instead, it can be either way. That means I'm going to call it a plus or minus 2.58. Okay? All right. Now, let me show you how it looks like in a chart form. It will be negative 2.58, which is possible. They have the center line on the right side. You still have the same 2.58. This is a two-tailed text. Okay? So you can draw the I can draw the chart. Put the line right here. Okay, pick this up from here and go all the way down. Okay. Now I can move it back. Okay. Now I can go now I can just move this back a little bit. Now this one can also move in. Yeah, a little change. Then move the center line back. Good. So I think I got it. So I can put the lines of demarcation. Well, this is for this one. And other one for the center line. And this is for the positive side of this. So we are going to so this is for the left side. The answer 4 in this shaded area. You reject my hypothesis. Similarly, if you fall in this shaded area, you reject my hypothesis. This B side in center is the accept stance region. If you fall in that center, you don't reject anything. Okay. Now, having that critical value, we can now run our test. Let's get our summary statistics. Okay. We are told that the Medical Rehabilitation Education Foundation reported that the average costs of rehabilitation for stroke victims is 24,600. Let me write it down. Meal is 24,672. Okay, so I'm gonna put right there. Okay, and the mean equals 24,672. At least that what it told us. To test this claim, we selected a sample of There is such as a random sample of 35 stroke victims at the hospital and find that the average cost of rehabilitation is 25,226. So N is 35 stroke victims. N equals, excuse me. N equals 35 stroke victims. And I found that the X bar, which is the average cost. X bar will be, it says, you're gonna be X bar, right? Yeah, something like me put the bar on it. Okay. X bar equals, finally, so that it is 25,226. N is 35. X bar is 25,226. Now the standard deviation is 33,251. Let me write this one first. 25,226. The standard deviation of the population is delta equals, let me write it down. Standard deviation is equal to 3,251. Okay. 3,251. Okay. Let me put standard deviation delta. Now with this, we can run the test. Remember the formula again. Formula is Z equals to S bar minus mean divided by standard deviation over root n. I want you to take a look at the values for this summary statistics. Mean is population mean is 24,672. Sample mean X bar is 25,226. Population standard deviation is 3,251 and N is 35. So we're gonna go and use it to run the tests. The other workbook will allow us to do that. So I'm gonna go there. Okay, move all this so we can now put our own values. Okay, equal. We got 25,226. And I was 24,000, right? Sorry, 24,672 divided by standard deviation over the square root of n. 3251. N is 35. So I'm going to square root of n, which is square root of 35. So let's put this on the calculator, see what it gives us. We're about to run the test. Let me write it down. Z equals 25,226 minus 24,672 over 3,251 was square root of 35. Let's go and put this on the calculator. See what it will give us. Okay. We have 25,226 and us 4,672. Okay, divided by 3,251. 3,251, which is standard deviation. 3,251. Over the square root of 35. 1.00815386, which is approximately 1.01. Yeah, 1.0. So I'm gonna put it on the our answer there, and then we copy it and paste on the main workbook. 1.01. Okay. I'll copy this right there. Okay. So it's gonna be this So now we can make our decision. Now you can see that 1.01 is the result of our test. It doesn't fall in the acceptance region. It's less than 2.58. So let's write down. First of all, let's write the critical value. Which is Z alpha over 2. Alpha over 2 equals, you got it at 2.58. Since the answer is positive, we only consider the positive side. So it's 2.58. So let's adjust this. Okay. Now, the calculated Z as our answer. Calculated value is our own Z equals 1.01. So you can see that it is less than the critical value. Now, assuming that we have something like 4 or 2.65, then we reject the null hypothesis. But this time we have a number that is smaller than the critical value. 1.01 is less than 2.58. So we don't reject. But if we have, let's say we have 2.59, we reject. Or even 2.58, we reject. So long as it is equal to the critical value or more than that, we reject null hypothesis. But if it's less than that, don't reject. So in this case, do not reject the null hypothesis because the calculated value of 1.01 is less than critical value of 2.58. So that's our decision. Now, since we are not rejecting this, remember the HO is where the claim is in this case. Since we are not rejecting the HO, that means the claim is correct. Okay. So we can write this as conclusion. Okay. Conclusion. There is enough evidence to support the claim that okay, what was the claim again? That the average cost of rehabilitation of true victim is this. Average cost of rehabilitation for true victims is is 24,672. Now, any question on this one, guys? Yeah. So no question. Let me don't go here. Let me double check the names I have here. I have everyone's name, but a few of them. Smith, Welch. I think I have Welch. I have Welch here. Parker. I got Parker. I got Chin. Because it's Smith. Dennis Smith. I got that one. Third. Got Chud. Who is the guest? Darlene, what's your last name?
Guerrero.
Guerrero, okay, got you. So who else? I got Jaden. Make sure I got everybody's name. Okay, I got Xavier. Oh, got it. Harley, I got Harley. Kennedy, Green. Got Kennedy. Kimura. Kimura, you here? Miss
I'm
Kimura.
here. I'm
Okay.
here.
Okay, I got you. You play basketball, Miss Kimura?
Yeah.
Okay. I saw one that's an email from, I think it's from your coach. Yeah. Hello. Okay, who else? That's Campbell. I got Campbell, right? Somewhere. It's Campbell. Miss Campbell, what's your last name? Campbell. Looking for this name here. I didn't see it. Campbell, you there with me? Kiana. Okay. Butler Bay, I got that one. Snow. I got Veronica, Hewitt, Xavier. I think I got everybody. All right, guys. I will see you in the classroom on Thursday, so I can put those of you who haven't given me the project. I will assign you to the group that you belong to, and then those of you that
I have a question.
yes, ma'am.
Hi, for the assignment classwork 9, null and alternative hypothesis, there's no question.
You sure about that?
Yes.
Let's check it.
It's a statement, but there's no question to answer.
Let's see it again. I'm sure that
She's right. It's no questions.
yeah, let's look at it. It's not math. It's not supposed to be math. It's just to state the hypothesis I want. Let me see. Okay, that was from last week, right?
No, it's due November 22nd, classwork 9. Oh yeah, there you go.
Yeah, let's see right here. Let's see this question right here. The average, it said, okay, I see what you mean.
Yeah.
So the state the null and alternative. Okay, let me put right here. I can put it right
You
there.
about to fix it?
Yeah, I'm about to put it now. State
All right.
the null and alternative hypothesis for this conjecture. That's what you need to do to see the conjecture right here. The average age of atoms is greater than 25.4 years. So state null alternative hypothesis for that. So that's what you need to do there. Remember how I showed you last week? How to state that alternative. And we even stated hypothesis today. So that's what I need you to do to state null and alternative hypothesis. Okay?
Thank you.
You're welcome. And thank you for bringing this up. Otherwise, I would have known. All right, guys. Any other
I have a question.
Yes, ma'am.
So you said that some of us were allowed to redo 5 assignments that
If
we're
you have
supposed to
if you have up to 70% attendance score, you can request for up to 5 assignments. Yes.
Yeah. We're supposed to email you those assignments, or are you
the name.
open?
Email it to me.
Okay.
Remember that each assignment in this class have a name, like classwork 1, test 1, So you choose 5 of them that you want to redo if your attendance is up to 70%. If it's not, then you don't have to, because you have to wait until it goes up.
Okay.
I need it today. Okay.
Okay.
Go to your grade book, see the ones that you need to, to fix. Then email them to me, the names. Okay.
Also, Professor, I have a question also.
You're the guy that said you want to ask me a question, right? At the end, right? Okay, go
Yeah.
ahead then.
It's for Excel assignment number 4. It said you told me I had no work shown, but like I explained in the comment section, it was the Excel sheet sent weird. Like it only showed the numbers from the data sheet and not the actual answers I did. So I sent a file into the comment section with everything in it.
No. Let's look at it.
Okay.
Let's look at it because it have to be on Excel. No
Yeah,
explanation.
everything was on Excel. The way it was sent weird. I was trying to explain that in the comments. Like it always
Let's look
happened,
at
but
it. Let's look at
okay.
it. But I can't accept comment. I only accept Excel file, and then I have to grade the Excel file. So let me see what
Yeah,
what
it's
you
I
have.
see the Excel file link into the comments.
Okay, let's see then. Let's watch it. Let's check it. Let's check it then. What's your name, sir?
Xavier Hewitt.
Hewitt?
Yes, because the way it's sent, but it wasn't an Excel sheet. It was just numbers going down. I was like, that's weird because I was going over all the like all my work because last week
Okay, let's
I made a
see.
mistake.
This is
So
right
I
here. This is one you sent to me,
yes.
right? Is this one you're talking about?
Yeah, I sent the video also.
Oh, no.
Like,
I don't need video. I need the Excel, Mr. Xavier.
yeah,
I
I sent
don't.
that as it's right there. Like you go up and click the link, it's right there. I've been show like I was just
Okay,
showing you proof.
this is the link you're talking about? This one here?
Yes.
Okay,
Yes.
let me open it then. Okay, see. Okay, see. Okay, this is the answers you get. I didn't see this.
Yeah, because that's what I'm trying to explain to you in the comments. Like it said
Okay, hold on.
weird.
But
Like,
let me give you that. This is the answers you have. Let me check your answers. I can see the work now. Because the other one I graded, it doesn't show any work at all.
yeah, that's why I was like, that's why I kept like
So let me
I would
see.
like
But you did you answered only 3 questions there though, actually.
yeah, can you say so you for me to find the first, second, and third of whatever he was looking for. I had followed the YouTube video you sent, and he also sent the formula in the assignment. I used those 3 formulas in Excel to find those 3 answers.
So give me 1 minute. Let me pull this thing out. Yep,
Okay.
got it. So you got this one correct. This one is correct. This one is correct. But you didn't answer the third one. So you have 75%. So let me write that way.
What was the third question?
I will show you in a minute. Just give me 1 minute. Let me put
Thank you.
75%. Okay. Because there are 4 questions, 25%, 25% each. Cool.
Okay.
Good. 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 No, I'm gonna show you the fourth question.
Okay.
Are you watching? Are you looking at the screen? You can see the screen,
Yep,
right?
I am.
Yeah. You're asked to find the okay, already Q1, Q3, and interquartile range. See?
Oh, okay.
Yeah,
Yeah, I see it now.
yeah.
Wait,
But anyway, you see the ones you did, you show. I see the work, you show the work, so you get a grade. It's just this one that you didn't do this one, that's all. So you're good now, right? Yeah, you're good.
I hope so. I'm gonna just double check my grade because I was like, I can't afford to take another 0 or whatever, a bad grade on an assignment. I'm just letting you know.
Yeah,
And
is now 75% on that, so you're good.
okay.
So now, if you're up to 70%, did you send the email? Are you up? Is your attendance up to 70%?
No, I'm explaining that I inbox you. I explain like I have been going back home in the school all this semester and my attendance wasn't the best. So you
Yeah,
told me last class.
The problem is that you didn't tell me all this. You're telling me now. So what I can do, Mr.
Yeah.
Xavier, is you have till 10th of December to push it up.
Okay.
That time you can request for makeup. Okay?
Yeah. Yeah, I apologize. I was just overwhelmed because I was kept going back home and back there because my grandmother health. So I was kept going back and forth. And I was just trying to finish work as I can.
Yeah, sorry about that. But I'm giving you a chance now too. If you can make it
Okay.
up to 65% by then, you let me know, okay? I will. Okay?
Okay. Now I'll let you know by then.
Yeah, all right. All right, guys, I see you on Thursday, okay?
All right. Catch you later. Thank you.
You're welcome. You all have a nice day. Stay away from trouble. I had something that happened yesterday at the campus. Please try and be safe, okay?